Okay. In the previous lecture, we have discussed about the heat exchange equipments or heat exchanger, and we have discussed about the different types of heat transfer equipments based on the function, that is cooler, condenser, chiller, exchanger, heater, reboiler, vaporizer, wasted boiler, evaporator, etc. So there are different types of heat exchange equipment or heat transfer equipments based on the function. The function may be a cooling, a function may be heating, that may be a condensing, that may be a chilling, that may be a vaporizing, that may be a evaporating, etc. So there are various types of functions which may conduct in the industry, and that is why on the basis of these functions we have classified this heat transfer equipment which is mainly used in the chemical industries as discussed in the previous lecture. Now we have also discussed about the double pipe heat exchanger, that is one of the main heat exchanger or old and conventional heat exchanger, where there are two tubes, that is concentric tubes, and we have discussed about the construction and working part, advantages, disadvantages, and application of this double pipe heat exchanger. Now the next and commonest example of the industrial heat exchangers are shell and tube heat exchanger. Now we have discussed about this shell and tube, but I will just recall in a few minutes what exactly the shell and tube heat exchanger is. So this diagram clearly shows you that this is the part of shell and tube heat exchanger, that is called as shell. So that may be a hemispherical head type shell, that may be a flat type shell. But in this shell, that is in the metallic sheet, there are number of tubes incorporated in this shell type assembly with the help of tube sheets and other parts. So the combination of this shell and tube and this assembly is used to exchange the heat. That is why it is called as shell and tube heat exchanger. So the purpose may be a heating, purpose may be cooling, purpose may be the other one like vaporization, condensation, boiling, etc. Basically, this shell and tube heat exchanger may be of one pass, maybe of two pass, maybe of four pass, six pass, etc. So what exactly the pass means? So when the one fluid, that may be from the shell side fluid, that may be from the tube side fluid. If the one of the fluid is passing in the heat exchanger along the length of this heat exchanger only once, if this fluid is passed along the length of this heat exchanger only once, then it is called as single pass shell and tube heat exchanger. If the pass partition, that is metal sheets, are incorporated, that may be for the shell side fluid, that may be for the tube side fluid. If the metal sheets are incorporated in a such a way that there should be two passes, that may be for tube side, that may be for shell side. So if you observe this arrangement for the tube side passes, so you can understand what exactly the tube side passes are. So if we incorporate these metal sheets on the channel side here for achieving the two tube side passes, so this tube side passes fluid is passing in this way, right? So if the tube side fluid is directing or guiding in this way or in a such arrangement that this tube side fluid can't pass through this channel directly. So for the guidance or the direction of this fluid, we have to add this metal part, that is metal partition in the channel part, and then this tube side fluid can pass in this way. Now if you observe, this tube side pass flows along the length of heat exchanger twice, and that is why this is called as two pass tube side heat exchanger arrangement. In a similar way, if you want to pass this tube side fluid 4 times in the shell and tube heat exchanger, then you can arrange the pass partitions or metal partitions in this way. So for achieving the 4 passes, you have to incorporate 3 metal partitions or 3 pass partitions. So the first pass is from this space, second pass is from this space, third pass is from this space, and fourth pass is from this space. So this tube side fluid particles or molecules is going to pass 4 times along the length of this shell and tube heat exchanger, and that is why it is called as 4 passes. So this pass partition welding or arrangement may be in this way also. That is depending on the requirement, suitability, fabrication, etc. So now in this case, the tube side fluid is passed through this space once, then 2 times, then 3 times, and then 4 times. So that is why this is called as 4 pass arrangement in the tube side fluid in the shell and tube heat exchanger. In a similar manner, you can arrange it for the 6 passes. So this is first, second, third, fourth, fifth, and sixth. So 6 times these tube side fluids are going to pass along the length of heat exchanger, and that is why it is called as 6 pass tube side fluid arrangement in shell and tube heat exchanger. In a similar way, you can arrange it on the shell side also. So if you observe this diagram, in this diagram, here shell side passes are mentioned. So from this nozzle, this shell side fluid is going to pass in this way. Now when this shell side fluid is passing in this direction, that is once along the length of heat exchanger, then in a reverse direction, that is in U direction, it is again passed along the length of heat exchanger, and that is why it is called as 2 pass shell side fluid arrangement. So for that purpose, you have to arrange the metal partition again in this area to direct this shell side fluid to flow in a such a way that these fluid particles, that is shell side fluid particles, should pass through the heat exchanger 2 times. And in a similar way, we can arrange this much or this type of passes in shell side as well as in the tube side. So when we are talking about the 1-2 shell and tube heat exchanger, that may be 2-4 shell and tube heat exchanger or other examples. So these numbers means this first number indicates the shell side fluid arrangement, that is shell side passes, and this second number indicates the tube side passes. Now in this case, in the first case, there is only one shell side fluid pass and there are 2 tube passes. So these numbers indicates how many passes are there in the shell side fluid and in the tube side fluid. In a second example, there are two passes arrangement in the shell side fluid and there are four passes arrangement in the tube side fluid. So these numbers clearly indicates the first number, that is shell side fluid passes, and second number, that is tube side fluid passes, right? So after discussing all these things, you can also understand what exactly the shell and tube heat exchanger assembly is. What are the different types of shell and tube heat exchanger is, and what are their functions. So from this diagram, you can understand how the tube side fluid and how the shell side fluid is going to pass. The different parts of this shell and tube heat exchangers are the nozzles. So this is the part from where tube side fluid is going to pass, going to enter. That is why it is called as tube fluid inlet. And this is the nozzle arrangement for tube fluid outlet. So this liquid can pass or gas can pass from these nozzles, and after exchanging the heat, this tube side fluid is going to pass outside this shell and tube heat exchanger, right? So this nozzle arrangement is there, and this is the direction how this tube side fluid is going to pass. So through these number of tubes which are available in the shell and tube heat exchanger assembly, this fluid is going to pass and then it is going to pass outside the shell and tube heat exchanger assembly. So in this direction, this tube side fluid is going to pass. So the different or main part is nozzle arrangement for inlet and outlet of the tube side fluid. In a similar way, there is nozzle arrangement for the shell side fluid. Here for the inlet and outlet, and this shell side fluid is passing in this direction. So for guiding or directing the shell side fluid, we have to incorporate the baffles in the shell and tube heat exchanger assembly. So you can observe this baffle arrangement in the two-dimensional diagram. It is shown like a solid rod or rectangular type, but in actual it is a circular type arrangement, because this shell and tube heat exchanger assembly is also a circular or cylindrical type arrangement. So if you go or if you observe the side view of this two-dimensional diagram, then you can understand this is a circular cylinder, circular shell, circular baffles, circular channels, etc. So this is the baffle arrangement in this way. So this should be touched, welded or joined to the shell. But in alternate way, if you observe here, intentionally the space is provided at the bottom, then in the next baffle at the top, and likewise at the bottom and at the top. So this space intentionally provided with the help of this baffle arrangement to pass this shell side fluid in the zigzag direction, right? So this baffles, which is normally having cut of 25% part, that is called as 25% cut segmental baffle, or it is also called as 75% segmental baffle. So these baffles main function is to increase the turbulence of the shell side fluid. So the primary purpose of these baffles are the increase in turbulence of the shell side fluid, and the secondary purpose is to support these tubes which are incorporated in the shell and tube heat exchanger. Right? Now, the other part of the shell and tube heat exchanger is tie rod. So these tie rods are incorporated in the shell and tube heat exchanger to support the tubes, because if the number of tubes are more or if the length of the tube is more, then these tubes may change their shapes, because normally we are using the straight tubes or U tube. So for supporting the weight of these tubes, for maintaining the straight direction of these tubes, we have to incorporate these tie rods. So the main function of these tie rods is to support the tubes which are available in the heat exchanger. This is another part of the shell and tube heat exchanger. Then this is the part where tube side fluids are passes through this part, and this part is called as channel, right? So this is also called as channel. So from this part, this tube side fluid can pass through the tubes, and again it pass outside the shell and tube heat exchanger through this channel only. So channel is having the different parts like channel cover. So for closing this tube side fluid arrangement, we have to add this channel cover, and this channel cover is connected with the channel part with the help of nut and bolt arrangement, and sometimes it is an integral part of that shell and tube heat exchanger. So for repairing and maintenance purpose, you can dismantle this channel cover from this shell and tube heat exchanger, and you can go for the repairing, maintenance or cleaning of the tubes or other parts of shell and tube heat exchanger. Now this part is again connected with this sheet that is called as tube sheet, right? So this part is called as tube sheet because the number of tubes are incorporated in the metal sheet, and that is why this part is called as tube sheet. So this tube sheet is connected to the channel cover. So these are the main parts of the shell and tube heat exchanger. So sometimes depending on the requirement, depending on the application and depending on the condition, we have to add some other parts like expansion bellow. So in this diagram you can observe this is the additional part that is called as expansion bellow. So there is a hot fluid and another is a cold fluid. So there may be a chances of thermal stresses development in the shell and tube heat exchanger. So to avoid the thermal stresses which may develop in the shell and tube heat exchanger, we have to incorporate the expansion bellow. So this expansion bellow can absorb the thermal shocks due to the large temperature difference in the hot and cold fluid arrangement, and sometimes we have to incorporate the U tubes instead of straight tubes for absorbing these thermal shocks or thermal stresses. So these are the main parts of the shell and tube heat exchanger, and you can understand the construction as well as working from this diagram. Now this is the baffle arrangement. So in the previous diagram you can observe the two-dimensional front view only. Now, from this diagram, you can understand how exactly the baffle arrangement is, right? So this is the baffle arrangement in a circular shape, and this circular part, that is 25% circular part, is cut for guiding or providing the space for the shell side fluid, and that is why it is called as 25% cut segmental baffle or 75% segmental baffle.
देखो ना मेरा लेक्चर चालू है.
Right? So from this diagram, you can observe the shell side fluid flow direction also. So this diagram shows the direction how the shell side fluid is passing with the help of this baffle arrangement. Then how the tubes are arranged in the tube sheets. So there are two possibilities which are popular or famous in the industries, that is triangular pitch arrangement or square pitch arrangement. So these tubes can be incorporated in the tube sheets with the help of triangular shape arrangement or with the help of square shape arrangement. And on the basis of these shapes itself, this is called as triangular pitch sheet arrangements, and this is square pitch tube sheet arrangement. So what exactly the pitch is? So the center distance, that is center to center distance between the adjacent tube, is called as pitch. So in this diagram, the center to center distance may be this one or this one or this one and this one. So if you observe the adjacent tube, then you can call this length, that is nothing but a pitch. So in the square pitch also, if you observe, if you measure this center to center distance of the adjacent tubes, then you can call it as pitch. So that may be a triangular pitch, that may be a square pitch. But the main concept or definition of pitch is the center to center distance between the adjacent tubes in the shell and tube heat exchanger assembly. Now there is another definition that is called as clearance. So if you observe the distance between the two adjacent tubes, then it is called as clearance. In the pitch, we have to measure center to center distance of the adjacent tubes. But when we are talking about the clearance, so clearance means the space between the two adjacent tubes. So the two adjacent tubes may be this, the two adjacent tubes may be this. So this is a clearance in the tubes, right? So the pitch is center to center distance between the two adjacent tubes, and the clearance is the difference or the space between the two adjacent tubes in the shell and tube heat exchanger. Now we can observe the other diagram, that is channel, and in this channel we can incorporate, we can weld a metal part that is called as pass partition. So with the help of this pass partition, we can add the number of passes in the tube side as well as in the shell side. But from this diagram, you can understand we can add the number of passes in the tube side fluid. So this is the pass partition, that is nothing but a metallic sheet or metallic part which is welded in the channel cover, and in this channel part, if you add this metal partition, then you can guide this tube side fluid in this direction, right? So on the basis of addition of this pass partition, we can change the number of passes in the tube side fluid, and in a similar way we can add the pass partition for the shell side fluid, and we can add the number of passes on the shell side fluid also, right? So that is depending on the requirement and depending on the condition, we can add these pass partitions and number of passes. So we have already discussed about this pitch and clearance in the triangular pitch as well as square pitch arrangement in the shell and tube heat exchanger. Now this is one of the shell and tube heat exchanger type. So there are different types of shell and tube heat exchanger, that is fixed tube sheet heat exchanger, floating head heat exchanger. The floating head may be subclassified as internal floating head, that may be outside packed floating head. Then there is another classification of shell and tube heat exchanger, that is U-tube type heat exchanger, where the U-tube tubes are incorporated in shell and tube heat exchanger. Then there is another main type of shell and tube heat exchanger is reboiler or kettle type heat exchanger. So this reboiler or kettle type heat exchanger is also again subclassified as reboiler type heat exchanger with internal floating head and reboiler heat exchanger with U-tube sheet heat exchanger. So there are different types of shell and tube heat exchanger, and this is one of the type of shell and tube heat exchanger. So we know the construction part, we know the different parts of shell and tube heat exchanger, we know how the shell and tube heat exchanger is going to work for exchanging the heats between the two fluids, that is one is hot fluid and another is cold fluid. Now in this type of heat exchanger, basically you must understand what exactly this 1-2 is. So we have already discussed about this 1-2 heat exchanger. Now it is a fixed tube sheet heat exchanger. So why this name is there? So what is meant by this fixed tube sheet? So you can observe from this diagram that these tubes are fixed with the tube sheets. So these tubes are the integral part of the tube sheet itself, and that is why it is called as fixed tube sheets. So for removal of these tubes, for repairing, cleaning or maintenance of these tubes, we have to remove the tube bundle, and this can be possible only when we have to remove this tube sheet. So this removal of tube sheet means removal of tube sheet including the number of tubes which are joined or welded or which may be an integral part of these tube sheets. So all these tubes are the integral part of this tube sheet, and that is why it is called as fixed tube sheet shell and tube heat exchanger. Now we know that what exactly this 1-2 is. I am repeating again. So this metal partition, that is pass partition, is incorporated in the channel for adding the number of passes in the tube side fluid. So by adding this metal part, we are going to block this tube side fluid for passing in this direction. So it is not possible for the tube side fluid to pass directly in this direction. So this pass partition or metal part is going to direct this tube side fluid to pass in a such way, right? So this tube side fluid is going to pass in this way. This tube side is going to pass in this way. And when this tube side fluid or the particles or the molecules of this tube side fluid is passing in this direction in a such a way that the particles are traveling along the length of this heat exchanger twice in this shell and tube heat exchanger assembly, and that is why this is called as two times or two pass shell and tube heat exchanger assembly. So two passes on the tube side fluid and only one pass on the shell side fluid. So if you observe this shell side fluid arrangement, so this shell side fluid is flowing in this direction like this. So these shell side fluid particles or molecules are passing along the length of the heat exchanger only once, and that is why this number is 1 only. And these tube side fluids are or the particles are passing along the length of heat exchanger two times, and that is why it is called as two pass arrangement. And in the combination of this shell side fluid and tube side passes, this 1-2 heat exchanger named itself, right? So this is the combination that in this shell and heat exchanger, the tubes are the integral part of the tube sheet, and there is a arrangement on the shell side fluid only one pass, and on the tube side fluid two passes, and that is why this shell and tube heat exchanger is called as fixed tube sheet 1-2 shell and tube heat exchanger, right? So from this diagram and from the previous discussion, we can understand how this exchange of heat in the shell and tube heat exchanger is done, right? Now in this diagram, you can observe there are more than one pass partitions. So if you observe this diagram first, so this is one pass partition and this is second pass partition in the channel, right? So we have already discussed, if you are going to add the pass partitions, then the number of passes will increase. Now in the previous case, there is only one pass partition, that is why two passes on the tube side fluids are there. Now in this case, there are two pass partition, so this tube side fluid is going to pass in this direction. So you can observe the direction of this tube side fluid, and like this, right? So these tube side fluids or the particles or molecules of this tube side fluid is passed. This is the first pass, in the reverse direction is second part, then again third, and this is fourth. So there are four passes as far as this tube side fluid is concerned, right? And if you observe the shell side fluid passes, so for the shell side fluid pass also, there is pass partition arrangement on the channel cover or the hemispherical head cover, which is on the right hand side of this diagram. And due to this pass partition arrangement, the shell side fluid is going to pass in this direction. Now check this blue color. So this is going to pass in this direction, and like this, right? So this is the direction of this shell side fluid. Now if you observe, when it is flowing in a such way, then one pass and it is another pass, and that is why this number indicates 2. So this 2 number indicates there are 2 shell side fluid passes, and this 4 number indicates there are 4 tube side fluid passes, and that is why this shell and tube heat exchanger is called as 2-4 shell and tube heat exchanger. The other parts and their function, construction and working we know very well. So the main part is the number of pass partitions incorporated in the channels, and due to that the number of passes are changed in the shell and tube heat exchangers. So this is one of the diagram where you can observe the 2-4 shell and tube heat exchanger assembly. So the arrangement maybe in this way also. So in the second diagram also you can observe the similar arrangement. So this is the pass partition and this is the flow of the tube side fluid. Then shell side fluid also. And then this shell side fluid and tube side fluid are indirectly contact with each other, and the hot fluid is going to exchange the heat with the cold fluid, right? So this is the 2-4 shell and tube heat exchanger assembly. So in this way, we have discussed about the shell and tube heat exchanger, different parts of the shell and tube heat exchanger, different classification and sub-classification of shell and tube heat exchanger, and their function as well as the working of 1-2 shell and tube heat exchanger, fixed tube sheet heat exchanger, 2-4 shell and tube heat exchanger, and in the next section we will discuss about the different arrangements and different types of shell and tube heat exchanger. Thank you.